Good day everyone, my name is John Jericho Arce from BIT2K, here to explain to you things you need to know about throttle position sensor. But first, what is a throttle position sensor? A throttle position sensor is a sensor used to monitor the air intake of an engine. The sensor is usually located on the butterfly spindle shaft so that it can directly monitor the position of the throttle. Purpose of a throttle position sensor. A throttle position sensor is used to measure how open the throttle valve is and therefore controls the amount of air which can flow into the engine intake manifold. The throttle position sensor is mounted onto the throttle body and measures the opening and closing movements of the throttle valve, and these are transmitted to an engine control module. This information, as well as other measurements including temperature, engine RPM, and mass airflow sensor, are used by the engine control module to determine the amount of fuel being injected into the engine and the spark timing. The throttle body system becomes more and more integrated in order to reduce system space and weight as well as material cost. TPS is integrated to the actuator motor in electronic throttle body. Types of sensors. There are two types: non-contact TPS, which consists of a Hall effect type and inductive type, and potentiometric type throttle position sensor. Construction of a throttle position sensor. As you can see here, this is the potentiometric type of throttle position sensor. And we have a resistive strip and multi-finger metal brush. So if you remember our past lessons, I've also mentioned that a fuel sensor works in this type of way, which there is a resistive strip and a multi-finger metal brush. And here is a diagram which consists of the slider, which is the rake brush as mentioned, and a resistor, the resistive strip as it's called. Now, why does it have four connection? We'll tackle that a little bit more in next slides. And here is what the inside looks like. Here's the rake and the resistive strip, as you may call. And a non-contact TPS. Now this type is the Hall effect type because you can see there's a Hall IC sensor and a magnet, which you can see this is a more clean type of sensor, especially this one because the throttle body is actually electronically controlled instead of being wired controlled like in older cars. And this one is the inductive type. So if you also remember in the cam and crankshaft video that I have made, there is also a Hall effect and inductive type sensor with a cam and crankshaft sensors. This also applies in uh, throttle position sensors, but it has different applications and also different function. And as you can see here, the inductive type has a rotor, conductive loop, and a stator in the PCB or printed circuit board. Operation of a throttle position sensor. Potentiometer TPS. A multi-finger metal brush or rake is in contact with a resistive strip as the throttle valve opens. The two potentiometer metal brushes moves across the resistive strip, changing the voltage divider circuit resistance values and sending the output voltage to the ECU. The ECU supplies the TPS with a reference voltage of 5 volts, TPS output voltage. TPS1 and TPS2 signal changes with throttle position. So you can see here the diagram of the main wiring. And you can see now why there are four connections. It's all going through the ECU or ECM in this factor. The first one is a 5-volt supply, and depending on the brand or maker, there is a TPS1 signal and TPS2 signal. And the fourth connection is the ground. So, as stated in the previous slide, the metal part or the rake um, brushes through this resistive strip. This strip is the one with power, and this one is the signal, TPS signal 1 and TPS signal 2 to be exact. Okay? And the resistive strip is the one with power and the other electronics. And a potentiometer sensor. Okay? TPS2 signal has a positive voltage offset of approximately 1.6 volt as compared to TPS1 signal for a fully closed throttle. So in this example, this is a fully closed throttle, both of them. So in the TPS sensor 1, you can see there is a 0 and TPS2 is 1.6. Now, TPS1, as you can see, seems like as the angle increases, the voltage also, I mean, yes, if the angle increases, it opens. It just goes linear ascent, while in TPS2, it also has a linear ascent, but when it reach around 4.6 something volts, it turns flat as differ from the TPS one that still continues to linearly climb up. Okay, next. Magnetic type TPS. This is the Hall effect type of magnetic type TPS. The Hall effect TPS makes no physical contact, so it will never be subjected to wear and have longer life cycles. Consists of a Hall IC made of Hall elements and magnets that rotate around the Hall IC. So unlike in the potentiometer TPS, the magnetic type TPS are, as it say here, non-contact. And that is a very great thing because instead of worrying of the wear, like in the potentiometer type, the Hall effect uses magnets which is needed to have a space for it to function. And we will tackle this in next slides. As you can see, in a magnetic TPS, there is a two-pole S and N, which is south and north. Magnetic disc is fixed in the shaft of the throttle valve. Its angular position is detected by an IC sensor aligned to it with a small air gap between magnet and sensor. So the magnets are actually connected to the throttle valve, and the throttle valve is the one that moves, so the magnets moves along with the throttle valve. So it means that the Hall IC sensor is the one that is stationary. And we will read it here in the next slides. The Hall effect IC sensor and the signal processing circuit board is mounted within the electronic throttle body, ETV gearbox cover, and it's stationary. So as I've said earlier, the Hall IC is stationary while it's connected to the gearbox, and also the processing circuit board is also connected in the ETB gearbox cover. The magnets are mounted on the throttle valve shaft gear and rotate together with the throttle valve. So, as I've said earlier, this is the butterfly drive. This is the thing that is connected to the throttle valve. This one is the gear that connects it to the motor. So it means in newer types of cars which has an electronic controlled intake valve, I mean, I'm sorry, uh, intake throttle valve. There you go. Um, Usually there are magnet types that are used, and as you can see, here is the magnets. There's only two. Okay. When the throttle valve opens and the magnets change their position, the Hall IC detects a change in the magnetic flux caused by the change in the magnet position. So this is pretty self-explanatory. While the magnet moves, the Hall IC detects it and then process it to send it to the ECU. The resulting Hall effect output voltage in accordance to the amount of change, this signal is sent to the ECU as the throttle valve open signals. So as you can see, there are two Hall IC sensors, which again means there is There are TPS1 signal and TPS2 signal. There's always a supplying 5 volts and a ground. Okay, and here are the magnets. The signal may be either an analog varying voltage signal or a digital square wave constant frequency PWM signal. Okay, analog means like in the potentiometer, or in this case, the Hall effect usually has a reading of squares. That's where it gets its name. Looks like squares here. TPS signal has a linear voltage increasing with the throttle angle at idle, with TPS2 signal is offset approximately 1.5 volts compared to TPS1 signal. Sorry for the errors. And here you can see in a Hall effect type, the TPS1 signal actually starts in, I believe, 0.5 to 0.6. Oops, sorry, I've forgotten the next slide. And in TPS2, it seems like it's 2.3, so it's much, it has a higher voltage. So now we can also differentiate and know if the TPS sensor is a Hall effect type, or, I mean, if the TPS sensor is magnetic or analog. Okay, you can see here, same as in the other type, potentiometer. Magnetic type, this is the inductive coil. So what's the difference with the IC Hall? We can read it here to know it. The inductive type throttle position sensor consists of a stator and a rotor. Rotor inductive loop is the dynamic part which is mounted on the throttle valve shaft gear. Okay, you can see here the rotor, which has loops of inductive loops. And throttle valve spindle shift gear. Yeah, I've already explained that in the Hall effect. A rotor is formed of one or more closed conductive loops with a certain geometry and is made of electrically conductive material or by printed circuit board PCB elements. So, unlike in the Hall effect, which seems much more slimmer and much more lightweight, um, the inductive coil still has the same principle as wound up coils, but this time it's a collection of conductive loop with a certain geometry. As you can see here, this is the conductive material. It might be metal, copper, depending on the manufacturer. Or sometimes, if it's not a conductive material, it's a PCB or printed circuit board with, again, a certain amount of geometry in it. And it is connected to the intake air manifold, I mean intake valve in the rotor here. So this is the one moving. And sensor and signal processing circuit board is mounted within the ETB gearbox cover and is stationary. The stator comprises a standard printed circuit board PCB and an application-specific integrated circuit, ASIC for short. So here is the stator, PCB printed circuit board. So instead of a Hall sensor, this one has a PCB board that is again stationary and is connected in the ETB gearbox cover. Okay, stator, electronic evaluator. This is the components that reads the signal of the PCB, the stator I mean. The printed circuit board includes planar exciting and receiving coils as well as evaluation electronics. So again, this is the evaluation electronics, rotor, exciting coil, the receiving coil. Okay. Transmit coil send a signal which is coupled back through a rotor into receiver coils, and IC is used to both generate the excitation signal and decode the received signal. The sensor output is flexible and can be both analog or digital, and redundancy can be achieved by integrating a second set up with a separate decoding IC on the same PCB. So again, unlike in the Hall effect, which can be run by one electronic evaluation control unit, in a inductive coil you need two, so that it can evaluate what type of signal it wants. It can be analog or digital. There you go. You can see it. And by the way, the reading of it is as same as the Hall effect type. So I haven't shown it. I haven't shown a graph of it. Thank you for listening.